Mates, I took the liberty of making a video, so hopefully makatulong ito sa paggawa natin ng exercise 2 natin for our advanced genetics. So I took the information from one of the problems I found in the internet. So this would be the grain type of rice. So there are 4 phenotypes here: yellow shrunken, purple smooth, yellow smooth, and purple shrunken. Now, the first thing na ma-observe natin dito is that there are 1, 2, 3, 4 phenotypes, and this is highly likely that it is a 9:3:3:1 phenotypic ratio. For the mere fact na ito lang naman 9331 ang merong 4 na phenotypes. And now in addition to that, we can see here that the yellow purple would be one character and the shrunken smooth is another character. So although hindi nakasulat sa problem, but this would be pertaining to the seed color, while this one would be pertaining to the seed coat. Now since it is highly likely that it is a 9:3:1 ratio, therefore we already have our null hypothesis and our alternative hypothesis. So we just write it down. The observed phenotypic ratio fits the 9:3:1 ratio, while the alternative hypothesis is that the observed phenotypic ratio does not follow or does not fit the expected 9:3:1 ratio. Now the question would be, how do we know if we will going to accept or reject the hypothesis? So we need a certain criteria, and that is where the criteria or this criteria comes into play. If the chi-squared computed is less than the chi-squared tabulated, we will therefore accept the alternative hypothesis. But if the chi-squared computed is greater than the chi-squared tabulated, we will reject HO, rather accept the alternative hypothesis. So how do we compute for the chi-squared tabulated? We need 2 information. First is the alpha, and the other one is the degrees of freedom. The alpha is already given, 0.05. For the degrees of freedom, the formula is n minus 1, where n pertains to the number of phenotypic classes, 1, 2, 3, 4. Therefore, it becomes degrees of freedom 4 minus 1 is equal to 3. Now, how do we get the actual value? Going to the table, we just proceed to the degrees of freedom since computed natin is 3, and then we proceed with where the alpha 0.05 is, and this is 0.05. Therefore, the chi-squared tabulated is 7.81. So if it's less than 7.81, we will be accepting the alternative hypothesis, while if it's less or greater than 7.81, we are going to reject the hypothesis. So how do we compute for the chi-squared computed? We proceed to the table. Now, one important step in computing for the table is to make sure that it is in a descending order. The original problem has the following: 21, 216, 65, and 79, but it would be more helpful if we're going to write that in a descending order, as we can see right now. So the purple smooth is 216, the purple shrunken is 79, the yellow smooth is 65, and the yellow shrunken is 21. So what do we do next? Now the next thing that we are going to be doing is we're going to compute for the expected frequency. Since the expected ratio is 9:3:1, kaya mas madaling isulat siya in a descending order is because you're going to be writing here the ratio. The 9, 3, 3, 1 ratio. But this is still incomplete because we need to compute for the expected frequency. So how do we do that? We need to get first the total of this, 216 plus 79 plus 65 plus 21. So we will have 381. Now in this case, bakit natin sinulat ito? Because we're going to be multiplying the ratio to the total. Now, the 9 is actually 9 out of 16, ang kanyang probability. 3 out of 16, 3 out of 16, 1 out of 16. And to get the expected frequency, we will simply multiply this with the total. 381, 381, 381, 381. With this, we will be able to get the expected frequency. So, 381 times 9 divided by 16, we will have 214. 381 times 3 divided by 16, we will have 71. The same thing here. 381 times 3 divided by 16 is equal to 71. And 381 times 1 divided by 16 is equivalent to 24. So the expected frequency will be very important in the succeeding parts. Next naman is deviation. So simply put, the deviation is observed minus the expected. So this is the observed 216, observe 79, observe 65, observe 21. And then we're going to minus the expected, which will be the following. Minus 214, expected, minus 71, expected, minus 71, expected, minus 24. Now let's get the answer here. 216 minus 214 is of course 2. 79 minus 71 is 8. 65 minus 61, 86. And 21 minus 24 is negative 3. Ito pala, negative rin pala to. Yan. So don't worry, there's no problem with negative kasi pag in-square siya, mawawala yung negative na yan. So what do we do next? The next thing is we're going to square the d. So since the d is 2 here, the d is 8, the d is negative 6, and the d is negative 3, we're simply going to square this. So the answer becomes 2 squared is 4, 8 squared is 64, 6 squared, a negative 6 squared is 36 with the negative disappearing, and 3 squared, negative 3 squared is equal to 9. The last portion here, or next to the last portion, is d squared over e. Since we already have our computed d squared, so we write here 4, 64, 36, and 9. We will be dividing that by the expected frequency. So the expected frequency is 214, expected frequency is 71, expected frequency is 71, and the expected frequency is 24. Computing for this, 4 divided by 214 is equivalent to 0.02. 64 divided by 71 is equivalent to 0.90. 36 divided by 71 is equal to 0.51. And finally 9 divided by 24 is equivalent to 0.375. Now we are still not yet finished because the next step would be to add all of this. So summation of d squared over e now becomes 0.02 plus 0.90 plus 0.51 plus 0.375, and that will be equivalent to your chi-squared computed. So let's add this all up. 0.02 plus 0.09 plus 0.51 plus 0.375, and the answer is 0.995. So our chi-squared computed is 0.995. Now with this, it's now easy to determine if it, since the criteria is if chi-squared computed is less than chi-squared tabulated, we will accept HO. The chi-squared computed is equal to 0.995 and the chi-squared tabulated is 7.81. Since 0.995 is less than, therefore we accept HO. Therefore, the conclusion would be since chi-squared computed is less than chi-squared tabulated, HO is accepted. That is, the observed phenotypic ratio fits the expected 9:3:3:1 ratio for a dihybrid cross that exhibit independent assortment at alpha is equal to 0.05, degrees of freedom is equal to 3. So that would be the first part of our assignment. We'll continue a little bit later.